Good morning, students. My name is Mrs. Nisha Patan Shetty, Assistant Professor, Department of Chemistry. So today I am going to discuss about one of the very interesting topic of engineering chemistry, that is determination of total hardness of water sample using disodium salt of EDTA. Okay. So firstly we will discuss about the principle behind this experiment. So basically this experiment consists of titration between the given hard water sample and standard solution of sodium salt of EDTA using erichrome black tea as an indicator, and the pH of the hard water sample should be strictly maintained to the range of 9 to 10. So this is a very important condition in this experiment. So talking about erichrome black tea is an azo dye and it has a deep blue color in the indicator form, and it has a property of forming complex with the metal ions like calcium 2 plus, magnesium 2 plus in the pH of 9 to 10. So the moment we add erichrome black tea into the erichrome black tea into the solution of hard water which is maintained at pH 9 to 10, immediately it forms complex with the metal ions, that is metal indicator complex, and that will be wine red in color. So because of that, immediately when we add the erichrome black tea, solution color changes to wine red. And when we start the titration with EDTA, slowly the color of the solution changes from wine red to deep blue at the end of the titration. That is because when we add indicator, the metals form metal indicator complex. But when we add EDTA, the metals from the indicator complex start forming complex with the EDTA, because the metal EDTA complex is more stable than the metal indicator complex, and also the thermodynamic of this reaction is more favored. So at the end of the titration, all the indicator molecules will be set free in the solution and the solution appears blue color, which is the original color of the erichrome black tea. Next, coming to the theoretical discussion. So what is hard water firstly? Hard water is the water which has excess amount of or excess concentration of calcium and magnesium salt dissolved in it in the form of metal bicarbonates or metal chlorides, or it may be in the form of metal sulfates. So when the water is hard, the main problems that may be in our day-to-day life activities or in the large-scale industrial areas. So the thing is, when we use the hard water, it is very difficult to lather the hard water. So it consumes lot of detergent or lot of soap for creating lather. Then coming to industrial problems, the hard water, since it consists of large amount of minerals dissolved, it forms a deposit or scaling kind of formation in the inner walls of the heaters, boilers and pipes, which reduces the efficiency as well as the lifespan of the equipment. The scaling formation in the boiler and heater exchanges, it can also affect in the reduction in the water flow and also increase in the pressure, which sometimes causes failure in the complete system. Then corrosion is also caused by use of hard water or excess of dissolved content in the hard water, which spoils the machinery parts or equipments due to the formation of immediate corrosions. This hard water cannot be also used in some of the pharma industries or food industries as well as the cosmetic industries. since the ions dissolved in the hard water can interfere in many of the chemical reactions or analytical parts or the analysis parts. And if we use hard water in the food industries, it can also impact on the quality, taste and appearance of the food products and beverages, which is also a drawback of hard water. So due to all this reason, it is very important to know the hardness of the water so that we can control that and minimize the losses. So basically, when we talk about hardness of water, there are two types of hardness. One is the permanent hardness and the second type is temporary hardness. So what is this temporary hardness and permanent hardness? So temporary hardness is when the calcium and magnesium ions are present in the form of their bicarbonates, and the permanent hardness is when they are present in the form of their chlorides or sulfates. So why bicarbonate salt of calcium and magnesium is called as temporary hardness? Because temporary hardness can be easily removed by just boiling the hard water. So when we boil the hard water, bicarbonate part of the salt will evaporate as carbon dioxide and the metal forms hydroxide. Metal hydroxides are easily precipitated and can be filtered. So we can convert the hard water into soft water just by boiling. That is why we call it as a temporary hardness. Whereas when we talk about the permanent hardness, that can be removed only by some ion exchange method, reverse osmosis methods or by chemical treatments. So that is why we call the chloride or sulfates of the salt as a permanent hardness. Next, talking about the procedure. So this experiment consists of two parts. The part A, where we have to prepare the standard solution of sodium salt of EDTA. For that, you have to weigh a known quantity of disodium salt of EDTA and transfer it to 100 ml volumetric flask. Dissolve the salt using demineralized water and dilute it till the mark. Next, part B is estimation of total hardness. For this, pipette out 25 cm cube of the water sample into a clean conical flask and add 2 to 3 ml of ammonium chloride buffer to this. Then add pinch of erichrome black tea indicator and start titrating against disodium salt of EDTA, which is already filled in the burette. So at the end point of the titration, color will change from wine red to deep blue or clear blue. Repeat the same titration for 3 more concurrent readings. So this is observation and calculation part. Part A consists of calculation of molarity of disodium salt of EDTA. So firstly, we have to take the weight of bottle plus disodium salt of EDTA. Secondly, take the weight of empty bottle. Subtract both the weight so as to get the exact weight of disodium salt of EDTA taken. Then for the molarity calculation, use the formula weight of sodium EDTA taken into 10 divided by molecular weight of sodium EDTA. So this gives us the molarity of sodium EDTA we have taken for the titration. In the second part, this is for burette readings. So final reading minus initial reading will give us the exact volume consumed for titration. So take average of 3 concurrent readings, that will give us the volume of EDTA solution taken for complete reaction. So conversion factor is 100 ml of 1 molar disodium salt of EDTA is stoichiometrically equivalent to 100.09 grams of calcium carbonate. So the total hardness of water sample will be expressed in the form of ppm, that is part per million. So detailed calculations and the conversion factor stoichiometric ratios will be explained in the experimental part. Thank you. Hello students. So now I will demonstrate about how to find out the hardness of water using EDTA method. These are the apparatus and chemicals required for the experiment. First is the hard water sample which has to be analyzed for hardness. Next is the disodium salt of EDTA, erichrome black tea as an indicator, buffer solution which is of ammonium and ammonium chloride. This is standard EDTA solution which I have already prepared, conical flask and a burette which I have already filled with standard EDTA solution. Now we will discuss about the first part of the experiment, that is preparation of standard disodium EDTA solution. So in part A we have to prepare standard disodium EDTA salt solution. For that, first you have to take weight of an empty beaker. Note down the value as a W1 disodium EDTA, the value as W2. The salt into 100 ml volumetric flask. After transferring this, dilute the solution and make it up to the volume, up to the mark using demineralized water. Now pipette out 25 ml of the hard water sample using a pipette. Now I have taken 25 cm cube of the hard water sample. Add 2 to 3 ml of ammonia buffer to this. This is to maintain the pH to around 9 to 10. Now add a pinch of erichrome black tea indicator to this solution, and you can see there is a color change of the solution to a slightly wine pink color. Now we have to titrate this solution against standard EDTA solution taken in the burette. So this is the end of titration, where you can see the color has changed to a blue color from the wine pink. Now note down the burette reading for the value. Do the same for 3 more trials to get the concurrent value. So this is the end of titration, where you can see the color has changed to a blue color from the wine pink. Now note down the burette reading for the value. Do the same for 3 more trials to get the concurrent value. Now note down the burette reading for the value. Do the same for 3 more trials to get the concurrent value. Now we will learn about the observation and calculation part of this experiment. In part A, we have prepared the standard EDTA salt solution. In first, this is the weight of bottle plus disodium salt of EDTA, which we have taken as W1, and W2 is the weight of empty bottle. W1 minus W2 will give you the exact weight of disodium EDTA salt we have weighed. For the calculation of molarity of EDTA solution prepared, we have to take weight of the sodium EDTA prepared divided by the molecular weight of sodium EDTA into 1000 divided by 100, as we have prepared only 100 ml of the solution. So that will give you Y moles of EDTA. In part B, the first, second and third reading that we have taken to get the concurrent reading of the volume required for the reaction, let us take it as a x ml or x centimeter cube. So conversion factor is 1000 cm cube of 1 molar EDTA is stoichiometrically equivalent to 100.03 grams of calcium carbonate. So x centimeter cube of Y molarity of EDTA will be equivalent to Z grams of calcium carbonate. So Z will be equal to x into Y into 100.09 divided by 1000. That will give you so and so grams per 25 ml of the sample. Analyzing only, so as we have taken only 25 ml of the sample in the conical flask, we will get the amount per 25 ml of the analyte. Now we have to calculate the amount of the analyte for 1 liter. So 25 cm cube of calcium carbonate is equivalent to A grams of calcium carbonate. Therefore, 1000 cm cube of analyte will be having x grams of calcium carbonate. So the x is equal to 1000 into A divided by 25. That will give you so much of grams per liter. So hardness of water will be equal to the amount what we get here into 1000. That will give us the hardness of water in ppm.